Hello my friends, and welcome back everybody. So today we are going to continue our work on the ECNTL fork and new workers, new master worker system in the RoadRunner. Let me check this. Or is it? Yeah. Xcali draw. By the way, it's super up. So I found it recently, and it's super cool. It like replaces all my needs for these kind of apps. It's like smooth, and can save your work on a disk. You can like use Dropbox to share it, so it's super cool. Yeah, and today, so yesterday we finished like preparation step. I guess like where is it? I don't need this. I think I need to leave a terminal. So yeah, where's our ticket? Should be somewhere here. Fork. Use of cache. Yeah. So yesterday we finished on the creation of like porting some functionality from the pull request from this ticket. Let me, by the way, found it. Where are you, my small pull request? Oh yeah, for command support. Yeah. And we started like moving some functionality from this like good old pull request to the our actual code, and yeah, we stopped on some kind of investigation related to the I recently deleted the whole my Dropbox folder accidentally. But however, it like they have a functionality to restore the whole file, so I deleted the terabyte of my backups. It was not fun. I wanted to open a book about like a Linux programming interface, but yeah, it's deleted now at the moment. But yeah, I'll restore it. So yeah, yesterday we had a problem that I supposed that if we would have a child and we will inherit the file descriptors for this child on fork when we fork our master worker, and if we send some data to the master process, it will be also inherited into the child. So to prove this theory, I just started to like reading Linux programming interface, but it seems that it's not true. So we can safely send the data, but however, we'll check this case. And I already copy this fork. Can we just leave somehow this only unified. One bit would be better. Okay. So this is some kind of generic. Why I push a generic here? Oh yeah, so I didn't want to change a way how we allocate a process, and this is called union of the types in Golang is. And so if you wanted to have like process interface, for example, which is actually is worker process or its child process, you can use union types like this. So, and it would be like compiled into both, and when you allocate this, for example, socket spawn, which is t pros, you should like specify what kind of structure it is like. Okay. Why I needed. Why I needed this fork factory? Oh yeah. I remember now. So let's copy it and let's put it not inside the socket factory, but inside a pipe factory. By the way, every day I'm using Vim, I'm so excited of its functionality. So I'm so happy. It's so cool. So for sure, I don't know all of the gestures and like keys, how to like key combinations, but today I realized a few super needed functionality of telescope. For example, if I need to like search something, for example, like git like this, I can then select all these files, and if I need to put them into some, into separate buffer to edit them, I just need to press M. Oh my god, I forgot. Telescope and now Vim. Yeah. Where is it? Yeah, Q. Yeah. Alt and Q. Let me just practice a little bit. And yeah, like this. And it will be in a separate buffer. And this is very cool. This is resembles some functionality, I think, from IDEs, like when you search something and you need to separate window just to go through all of your search results. Like here, you just need to save them to edit something, for example. And I needed today I needed this functionality too much because I needed to change in the like 10 documents a few lines. So I can do this with some search capabilities of the Vim, but I needed exactly this functionality. So to to use it like this, and this is super cool, Just letting you know. Okay. So what is the problems here? So first of all, we don't need we need a socket spawn, which is a generic function here. Yeah. But why do we need why I needed a separate worker here? I don't know actually. allocator fork. Yeah, so we already copied this. Fork pool. Yeah, so this is pool specially designed for forks. Childs. Yeah, this is our interface, which we have to slightly update, and this interface is located inside the API. Oh no, I don't know. Let me check. Yeah, we definitely have some Go files here. Plugins v1. I think no. I think that we have yeah. So we have this IPC interface inside the IPC folder somewhere. IPC interface. Oh, inside the pool. Yeah, so we can easily update it. So without like touching anything outside of this SDK. Ta-da! This is nice. Oh yeah, this is how to replace the dependencies. But by the way, Anton suggested me to use a symlinks, so this is the faster way to have the ability to edit something inside the PHP, and at the same time doesn't like change anything every time you like pushing this into pushing into the GitHub. And this is the way how we can use it without symlinks. Yeah, I remember this. So this is just we can just specify type and specify a URL, and this would be for the RoadRunner worker. Yeah, so we definitely copy this into our new code. Let's do this. RoadRunner PHP worker. And let's switch to the branch with name feature forking. Cool. I don't know, do I have some linters inside for the PHP? I don't know. And we need to jump right into mouse charger. You already charged. One commit ahead, and this fork process PHP. Fork process PHP. Oh, this is okay. And empty command. This is inside payload factory. Payload factory. Okay, and yeah. And here we have this fork command, which will fork our process. Nothing for our Okay, so I don't understand anything inside this PHP code. Well, this is kind of strange, right? So I'm working on a SAPI right now, and this is kind of strange. I think work on a SAPI without no PHP knowledge at all. So this is super strange, I think, because I only thing I need to know to work on the PHP SAPI is like C, to see how it works inside PHP SRC repository. It's it. So I don't need anything. I don't need to know PHP at all. So I need just a few functions, know how to write some functions to test this. Okay, so I still don't know why I decided to rewrite this worker. Let's check Okay, so we definitely need this this new function, but it's inside a worker Go, so I don't need to rewrite anything. So let me just copy it and put somewhere here. Yeah, so internal fork and relay. Yeah, so this will navigate us to our fork function here. Oh yeah, this is a fork command which we use. Yeah. So now I get it. JSON fork. Yeah, so it's not unused. Yeah. And that's it. So basically that's it. So very small fraction of the code here. Take worker. Oh, this is, I think, something unrelated to the current functionality. So this is, now I get it. So this is not about new master worker. Yeah, this is not about my rewrite of the pool. This is about the vector. So by the way, how all of this feature works. So we have do we have pages here? Can I just open a page number 2? Or just like endless? I think this is only one page. Save to, export, live collaboration, reset the canvas. Open. This is live collaboration. This is library. Browse libraries. This is I think something cool icons or elements to extend the functionality of the okay, but still, while it's endless, it's I have no problems with it. So how everything works, how RoadRunner actually works with the workers. Imagine we have a happy Laravel user who actually switched to Spiral framework, because previously he was unhappy. So I'm just joking, I respect all frameworks. And he sends a request. We have like, for example, in this case we have an HTTP plugin. HTTP plugin asks the SDK. This is a core, let's say, core libraries of the RoadRunner which we are currently working on. This is like here. This is an SDK. And then SDK asks SDK like, could you please give me a worker to execute some data? So SDK is decoupled component. It's not coupled to any plugin. It just provides some functionality. So it's like the through development kit for the plugins. It can say, okay, so here you are for the server plugin. Here you are the worker pool, and I'm going to manage it. And how it manages this? SDK have a stack. I'm a bad painter. Have a stack with the processes like worker 1, worker 2, worker 3, and big worker 4. And previously I mentioned that when you're trying to get a worker, this is a constant operation. So because we just use a stack, so this is O1. So you can there's no some kind of delay. You can allocate like 100, 1000 workers it actually doesn't matter on the speed how we're gonna get all of these workers. Where is it? Oh. Yeah, and then SDK asks this abstraction called worker watcher. Oh, no, worker watcher would be a little bit later. This is our stack. Actually, it's called like vector in our case. Vector. So vector is managed by the worker watcher, because we have to manage all of the workers and have to manage their states and all of the features related to the workers. So here is our worker watcher. And SDK basically asks from pool, which asks from the worker watcher, could you please give me a worker? So vector is basically a super performant Golang channel, which only responsible of like pushing the worker into the stack, releasing it, and like let's say releasing all of the workers. But worker watcher is responsible to watch for all of the workers, like their processes, like their states, if we have a proper state for the worker. So if we give to some HTTP plugin worker with the ready state, not like in the working state. So it manages all of the states. It manages waits, reallocations. So it basically watch for all the workers. And when SDK asks for worker watcher, please give me one, it just responds with like, okay, so let me check. It checks if it have workers, but it's not touching vector at all. It just checks, do we have enough workers in the vector? And if we do, it like just, okay, so I'll try to extract one. It extracting one. Check the states, check everything related to the worker, and then receive it like back to the SDK in the proper state. All of these things related to the process management is inside the worker watcher. And then pool just releasing this worker to the HTTP plugin, and HTTP plugin is capable of execution some kind of code inside this worker. So this is kind of simplification of the what's happening inside, but this is explaining how actually RoadRunner works. The problem of worker watcher here is that worker watcher is super complicated piece of the code. It should manage all of the features related to the processes. It's kind of let me show you how it looks like. Here is a worker watcher. So, and a lot of things inside the worker watcher related only to the performance of execution, because it should not be visible on the profiler. So worker watcher should be like invisible, and it's like it doesn't exist. So here is a function which used to take the worker actually, and this is just touching the container. Okay, so could you please give me a pop? A worker checks the states, comparing the states, if not ready. So if it's ready, just return. So this is a happy path. So it's like called fast path. And slow path is if worker is not a state which we need. And if worker is not in the state which we need, so we killing this worker, and the kill gets here, like inside a wait function. I'm sorry. This function. And this function is responsible for reallocating, for removing from all of the data structures inside the RoadRunner this worker. Like, so we are trying to store a pointer to the workers, not the workers itself, just to have shared access from different places of our application. And this is also allows us not to block execution, so we can just if we're ready to check the pointer, we can block only on the checking the pointer. So all other work related to the checking the states, this is atomic operations, so all of this kind of stuff is not blocking our workers. Yeah, so and we allocate these workers, so this is how basically management of the RoadRunner workers looks like. And all of this kind of stuff is so lower level of the RoadRunner, and then we have a pool. We have a static pool. Static pool is because it's static. It have static number of workers, like 10, 12, 20. Like it's not allocating worker dynamically. And this is a pool. So pool is only capable of execution of the workers. So it's not checking states. It's only just like, okay, I have a worker. I have a worker. I have a code. I have some code you want to provide it. Apple Pen, done. So, and that's because RoadRunner is decoupled, have a lot of decoupled components, so it's not too hard to, for example, to introduce a new type of worker, which is called forked worker. So, because we have this abstraction, so we can completely remove pool, for example, and replace it with another pool, let's say dynamic pool, and all other things like worker watcher, vector will be still be the same. If you wanted to have, for example, we found a critical issue in our worker watcher, we can safely remove it and rewrite, introduce new one without changing the interface. So it's kind of easy. Okay, and this is our new master worker. And I'm trying to steal. So this new master worker is in a fork pool. So as we see here, we have a static pool and we have a fork pool. And the fork pool, I think, have only one function, fork. Yeah. Destroy and reset. Take worker. So we still need some kind of management of the worker, because even if it's a master worker, so we still need a worker watcher to handle restarts of it. We still need some kind of small pool for it, to take it and send a fork command. So yeah, we definitely do need a new type of pool. Because we can't, so I'm trying to think, can we mix this worker, mark it somehow with other workers? I think no, because it won't be possible then to, so if you get this worker for execution, it would lead to crash, I think. I'm also thinking, do we need a pool? If we can get only worker, we can just where we can store it. No, it's not gonna work. So we definitely need a new fork pool. I don't know what is a better name for this. And pool master worker. Okay, why not? Pool master worker go. Okay, and this is kind of, oh, this will copy these messages. Can I hide them? No, I can't. Okay, let's. I don't think we need these imports. We'll edit while we be in the process of editing this thing. This is super uncomfortable to to edit like this, bypassing these messages. I'm trying not to miss any bracket here. Okay. IPC interface. Oh yeah, we also need to edit. Okay. So next we need to resolve all the issues. Fork pool, what is it? Undefined. What is undefined? Type no. Oh, yeah. Worker watcher. What kind of worker watcher we have here? Do we have an interface? Worker watcher. Yeah, so we can just copy some data. Some data right from our main repository. Worker watcher is fine. Okay, so undefined child. Yeah. And this is the problem of going way, let's say, receive an interface, return an structure. Because currently we are returning a structure which is process, yeah? And we created, here we have a new, like completely different structure called child process. And the problem is that they are different. So if we return an interface here, so the same interface, but we'll so just add a new function. It will be still the same interface. We won't be needed to update this function signature. But now, and we can't include this into our pool, into our pool interface. We can't include this function fork, because if we include it, we bind our pool, static pool, to this structure, which is not going to happen, And this is how this principle breaks the good architecture of the application, I think. Because in the static pool, we don't need this. So we can use generic and union types, but I don't think I want to do this. So generics in Go is still kind of slow. Yeah, so this interface. We have to add this fork method to this interface. Yeah, so I'm good with this. Because we definitely need this. Oh, and here we also have child process. Why we just can't? Why do you need a separate process for this? It's not IPC, it's not storage, it's not allocator. Options. we don't have any options in new implementation, by the way. Oh yeah, we also have to add a supervisor somehow. Composer child, yeah. Okay, and what are the differences here? Reproduction, FSM, state, relay, everything is the same. Oh yeah. So this is my attempt to, to it's so funny. Let's see. This is poor attempts. So this is my attempt to I tried to use this pdfd open system call, it like 434, but I was failed because I used like kind of old Linux kernel, and at the time I used this call, it was not implemented. But I can't wait. I can't use wait for. I also tried to use syscall 6 here for the syswait ID, because we have. By the way, wait for is not wait for system call is not a POSIX compatible. It's only BSD style. So POSIX compatible only wait PID. This one. Yeah, and like stated in the description. So wait PID or wait ID is preferable. So the wait for are similar to wait PID, but additionally return resolution information like error usage. Yeah, and I used wait ID. So this is the same. They all from the same family of waits. Like, yeah, a state change is considered to be the child is terminated. If a wait is not performed, then the terminated child remains in the zombie state. See the notes, as I mentioned yesterday. Yeah. So that this is the problem. A child that terminates but has not been waited for becomes a zombie. The kernel maintains a minimal set of information about the zombie process, speed, termination status, resource usage information, in order to allow the parent to later perform a wait to obtain information about the child. So yeah, when wait system call removes this process table entry. As long as the zombie is not removed from the system call via wait, it will consume a slot in the kernel process table. Yeah, and if this table fills, it will not be possible to create further processes. If a parent process terminates, then its zombie children, if any, are adopted by init1. And this is, I mentioned yesterday, that if you kill the master process, if your process is like alive, it will be adopted by PID1. So systemd init, like this kind of stuff. And also init1 automatically will remove the zombies. So if we have a zombie, we can just kill the master process, and all processes becomes childs of init1, and init1 will handle the removal operation of the zombies. But still we need to reallocate our master worker, and I don't know how would opcache behaves on this. So do we need to reallocate, not reallocate, I think, do we need to I don't know, perform some operations to somehow reestablish a connection to the previous opcache. I don't know how it works inside PHP yet, but we are going to understand how it works. Okay, so this leads me to a conclusion that we actually don't need We actually don't need a new structure here. Where is fork for this child? Oh yeah. So we would have a slightly different wait function. So this is because I needed to have a new child like structure. Lock onto waitable. Yeah. I'm going to resolve this with just a flag, I think. So because I don't need to create a completely like separate worker just because of only one function wait. So if we would be able to block. Oh, by the way, let's try. So let's figure out, because I'm still, some kind of skeptical about this. Let me open my Go playground. And let me open Obsidian. Oh, I don't have. Do I have my notes? Oh, yeah, I have it. I have them, so they already downloaded. But I lost. No. I lost all of my notes about this. Okay. Where is it? Wait for the chat. Yeah. Well, let's try to wait. Let's go into the temp folder and let's just test this piece of code I wrote recently. How recently? Like a year ago. We need to specify a PID. So let me think. What program? I don't want to write some kind of bash program. Okay. Not inside the time, not inside the temp. Create file tmp2 and main go package main. We have now a func main. I just wanted to see, do we have like some kind of snippet for the func main, like fm, and here we're going to just time sleep times second times just like super easy case, just 20 seconds. And let's open terminal and let's go to this temp2 folder. Okay, go build -o sleep. Yeah, it works. And let's check for its speed. Yeah, we have the speed. Okay, and let's go to this program and let's start it out. Let's start. I think I need slightly more time. sleep, like, okay. Where is it? Oh. So then no go files. I'm not okay. So I think let me just I can't compile it. Okay, let it be like 1 minute. Like 320 202. Oh, yeah. It's waiting for something. Let me now wait. So let's wait a little bit. It should exit after this process exited our sleep function. I can also write like, you know, some CLI tool which I provide a PEAT from a different process, but yeah, I needed only a quick check that my my function still works. Okay, yeah, and this function exited. Cool. So now we prove our theory that we can wait for a PID here. And this is basically everything what we needed. So we can easily replace I'm thinking about what we can do. So if we have, like, imagine a case. I don't want to use a wait function inside the PHP because it will block, and I don't want to handle, you know, I don't want to handle cases so where you need some kind of complicated processing inside the PHP. Instead, I'm thinking about of doing the following. So if we have master worker, and master worker have child 1, which are actually our workers, child 2, child 3. So we can have another command here called, let's say, wait. So nowadays we have a fork, and then we would have a wait command. So when the function exited, so we are not able to kill the zombie, you know. So if it like inherited by the PID1, this is fine. If it dies, so for example, this is orphan, this child, because father have died. So, and PID1 as recently read, so PID1 will handle all of the cases. But if we, so we can have it 2 cases. If we send a wait command to the worker which already dead, so we dead with this child and child's inherited by the PID1. And second case, if it alives and it have childs, and you know, we can just simply send a wait command, and it will use a pcntl wait function to remove from the kernel process table So it will not wait, it will not block anything, because it will just remove from the current process table. This will completely solve our problem of handling signals. So we on other side, so here we would know that process exited, and we need just to resend this command. So okay, please, I know that the process exited, so could you please remove this from the current process table, please? So, and we can have two types of the responses. First type of the response, if we send to the restarted worker, which childs are inherited by the PID1 already. And we can have a case. Imagine this situation. So, you know, there are a lot of cases which we handle inside RoadRunner. As you may see here, it's just some simple, like, piece of functionality and such much cases. So we have a master worker, yeah? And we have to predict all of these cases. This is like kind of bothering me. So we have, let's say, 10 workers. So RoadRunner knows that we have 10 workers. All of them are alive. But we have like 3 workers allocated on the current master worker process, and we have 7 workers which are inherited by the PID1. Like RoadRunner knows about all of them, but only 3 of them are handled by our master worker. If this worker dies, like one of this from this brave 7, like it becomes 6. So in this case, we receive a notification that the process exited, and we send a notification to the master worker. So please use a wait and remove this. And master worker should handle the cases if it waits, but it can return an error. So an error, as far as I remember, error would be no exists, something like this. Let me check. Oh, so bright. I'm sorry, guys. Yeah, it would be each child, as far as I remember, because the current process doesn't have any unwaited for children. So for this, you know, for the speed. By the way, could we PCNTL wait? Can we pass? Yeah, we can pass flags, we can pass status versus usages. Can we pass a PID? That would be like quite surprising, you know, if we can't pass a PID. Oh, we have wait PID, yeah. Good. What is this? Yeah, we have wait PID. So not wait PID, yeah. So our theory is still capable of be realized in the code. Okay, so I think we can safely now integrate this code inside the RoadRunner. Let me double check. So we don't need this. Don't need this child process. We only need worker process. Okay. Any child worker. Yeah, so we don't need. The only one I think problem here which we can face with is logs. So I think we should somehow turn off std_error from our worker, just not to read all of this kind of stuff. But let's see. Okay, so this is, we can resolve this problem a little bit later. So so since there is no difference, so since there's no difference between a fork worker and spawn worker with timeout, actually, except of we just need to understand that this is kind of worker is will be used for forking, as a master worker. I'm sorry. In this case, we only need to know to provide some kind of flag here. Like flag, let's say it's fork, is master. And if it's master, no, I still think no, we don't need this. Yeah, we definitely don't need this. We can initialize the base worker but we needed to update only one function. So we need to include this one into interface like fork, yeah? And we need to update our wait function. Wait, let's call it, so we can pass an argument here like wait is master like bool, like this, yeah? And then we can switch like switch is master, case false, this is expected case, and case true, this is for the master worker. And we need to put this wait into a separate function. Wait, let's say let's call it wait pid. Yeah, error, and return worker wait pid. Yeah, and the second function would be called like function wait process sys there's a number cspeed fd open speed of the open, let's call it speed fd open wait, and also return an error. Yeah, this would be return, yeah, let's just put a placeholder. What kind of missing return? We can also have two cases, like true or false. What are you searching for? Something a little bit true, yeah, a little bit false. Why? So, go, are you drunk? False, true. I don't understand after Rust. Okay. And here we're going to put our code Let me just slightly forker PDFD open go. Package worker, okay, and I need a main function. Yeah. Okay, system call, process exited. Yeah, so what's going on here? So Pol FD is this structure which receives file descriptor, events, and read events. So we need only to handle Pol in event with this one. Just to, let me check. PDFD open system call. So PDFD open non-block and file and use node events. To obtain file PDFD open. Oh, it can also obtain file descriptor. This is cool. Yeah, this is our case where what we need here for the events. Monitor file descriptor for process exit as indicated by the ePol in event. So here we are just listening for this type of the event. So this is basically, I don't know where I get this. I just experiment. I think I found this code. I rewrote it from this among pages in Golang, how I did with in process communication, for example, from C. Let me just update some. Let it go like wait. Syscall number. So okay, so and we are polling until we just like this, so until we're ready. And unexpected poll event, yeah, so we can also return an error if our event so event we are listening for is not actual event we are waiting for. So and to check this, we can just apply an AND operator, and if for example this event's bid would be not equal to 1, like 0, and here would be a 1, the total result would be 0, which is not equal to poll in, which is 1. So this is how AND works. And yeah, so and nil will indicate us that there is nothing, no errors, and we can safely send a wait command to the worker. Okay, good. And where is our yeah, and here we just need to We also need to use close for the speed. Let me just double check. Close Golang. This file generates is close. System close man. We can actually skip this part of closing the file descriptor because I'm not actually sure that we do need to do this, but okay, so let's see how it works. We need this. Okay, first of all, we need to obtain our PWD open function, and we also need to provide a P here. We have it, and PWD return an error. Okay, not enough calls. We don't actually need any flags here. PWD open. What kind of flags? Okay. Flag is not valid. The flag's argument either has the value 0 or contains the following flag: PWD non-block. So exactly what we don't need to do. PWD non-block. So we have to block. Okay, so we can basically skip this and just pass 0. So don't actually need to PWD declared but not used. Go, please. Please stop. And PWD if error is not equal to nil, return error. Okay, so it should look like this, I think. So let me double check. So if it's not a master worker, we but goodbye, like backwards compatibility. This is not a major release, so you know, this thing, we break the interface, but we declare this interface in only this package. So I hope no one will, like, you know, blame me for breaking the wait function. I hope. So okay, what's happening here? If it's not a master process, this is likely case because we are going to allocate way more workers which are actually not a master workers. And if it's true, we are using a different wait mechanism. So we are using PWD open, obtain performing a syscall here. Then we are using defer to close this file descriptor, and then we are waiting, right? Like we waited here. Also, here we are using this, you know, since we have information about the state, we also can get this information about the states and everything related to the states from this runtime, because you know we can thread and errors returning from the process and pass them to the some kind of a handler. I don't think that we actually need to do this. Okay, so two new function was added. I'm sorry, one function was added to the worker interface, is fork, and function wait was updated. And let's start receiving an errors. So it will definitely be an error somewhere here. Oh no, in the worker watcher, I think, not in the tests. Yeah. And now we should also, by the chain, as is expected, update all our function who calls this wait function. So how we can determine easily, I think. So workers is master worker bool, and we can pass an argument is master and like this. And just use it here. Okay, and regarding to the pool, from the static pool, we are not going to be, so for the just regular static pool, we're not going to yeah, this is master, that's the last, yeah. This would be false. Okay, and for our master worker process, this definitely would be true. Okay, and we don't need to have this, only need to have worker. Factors undefined, yeah. We also are not going to have debug functions, you know, all of this kind of stuff related to debugging. Because who would like debug master process worker except us? New master worker, and okay, so true. And where's our factory? Yeah, here you are. Fork worker. Not, yeah, and this is the point where we should decide that we need to change spawn worker with timeout function. Or no, we don't need to do this, because we can pass this factory, this argument here is master and bool, and we can just allocate it here. We don't need to change interface. Whew. And here we just pass in f is master, but yeah, let me think a little bit. So this wait function, I did this wrong. So we have to wait only on childs of the master. So if the child allocated with the master, only then we need to wait, but we don't need to wait the master worker itself, because it's our children. So we don't need to wait a master worker with this mechanism. We only need to wait workers allocated with master worker. So the child of the master worker, we only need to wait for them with this function. And yeah, I think I'm correct here. Okay. So all workers we allocate and yeah, so that is not correct. So inside a static pool we would have workers, children of the master process worker, and they would be not false, they would be true. So since we entirely wanted to switch to this new mechanism, so all of the workers allocated with this pool would receive a true here. But why then we need this pool? This pool we need only to, let's say, spawn worker with timeout. Yeah, worker process can use this. I think we don't actually need a separate pool for this, because I mean a separate abstraction like fork pool, because we might allocate only one worker on a static pool. Passing this argument, this is not a master worker. This is kind of tricky, you know. So we have to pass that this worker is not a master worker, but it actually is, because this is our child like of this run process, and we can wait it like we regularly wait our processes nowadays. But when we send a fork signal to this pool to allocate new workers with the new allocator, then we should pass a true is master true to them. Yeah, because they are children of not our parent. This is children of the master worker. Yeah, and to do this we only need to update our pool interface and include a fork function in it. And this fork function will be used only on the master process to allocate a workers. So pool will provide us workers with this fork function. But actually we don't need to do this. We don't need to do this because worker allocate pool allocate workers itself. So we don't need to like somehow inject into this process. The the pool is capable of allocating workers without our. So it have allocator inside it. So we only need to update our allocator. Oh, this thing, new forked workers allocator. Yeah, and we have to pass. Let me think. We have two type of factories now. We have a factory which is related to the like no. We have to like oh my god, why? We have this pipe factory, yeah, and we have is master, but we can we are able to pass only one factory to the pool. So it can be either master factory or not the master factory, yeah. So we can't allocate a forked worker master worker and at the same time allocate the children's on it, yeah. We can do this. Okay, how to resolve this? Things getting hot. I don't like to update to have a lot of abstractions which we want to use actually, like pool master worker, static pool, the children's, and etc. Instead I wanted to have only dedicated functionality. So we can also, so we have a we have an options actually. So in Golang, if you needed to have a function or like let's say constructor which is going to have which resolve different functionality, different purposes, and this problem solves with options. So options here, it's like optional argument, which options like optional options argument, and this it can be nil, so you can pass without them. But if you pass an options, then it will not break some kind of backwards compatibility like we did with this wait function. Can we actually use this init base worker? Oh yeah, so this is how this pattern looks like this options, and inside an options we have so this is just type alias which applies on your process. So this is kind of super easy to understand concept in Go. I'll show you a little bit later how it works. And passing these options, we can actually use here is master, like this, and we can pass this in master through the options without breaking changes here. like this. But still, we need to break this function. Let me think. We definitely need a function to fork, to like fork this current process, to provide a worker. Yeah, and this is how options actually looks like this. And master process, bool, and here just is master, and you can just pass like any number of these arguments to the end of this function. So this will lead to some kind of configuration. So this structure which we return process will be way more configurable without introducing any breaking changes, because it can be used in the base form without these options at all. So you can like just skip specifying these options, or you can, if you have an options, you can like extend the functionality of your structure. So in our case, we need to add this in master, is master, without breaking any functionality, but still we are going to break it with this fork. And what we are going to provide with this fork? With this fork, we are going to allocate the workers. And our allocator actually inside this static pool, yeah. But wait, this is the allocator, yeah. This is actually an allocator. And this, yeah, you know, it just returns an allocator. So we can easily replace it with our, so if it's master allocator. Okay, so so if it's supposed to be a master, yeah, we just need to pass to update this allocator and pass a thing. This won't be a factory anymore. So we are going to return an allocator, yeah, but we are not going to use actually a factory here, because with a factory here we're just asking to allocate a new process. Like, could you please fork exec this command, for example PHP, some kind of framework.php, so index PHP. Could you please fire this process? Okay, thank you, next one, thank you, next one. But in this case, with the master worker, we have to use a master worker to allocate our like process, not a factory. With a factory, so providing a factory to the new pool master worker allocator, let's say it could be like this name, we are going to ask a master worker to allocate our workers. Like, could you please fork yourself? Could you please fork yourself? Okay, and it's like forking, and we obtaining PIDs. So only thing we need to have only PIDs, so nothing more. But we also needed to connect to these PIDs. Oh yeah, so I forget one important thing here. We also needed to connect to these speeds. This is a problem. So while weight is solved, this is no problems with weight. We should so let me show you how it looks like with like, let's say, pipe factory. Yeah, so we are using this SID pipe. Yeah, so we are piping, so we needed to use a pipe system call like we used like previously, you know, with in our Rust application. So we need to call this OS pipe. And since I know how to do this in the terms of system calls, yeah, we let me no, it's this is not inside this folders, this is inside spiral gorge. Yeah, this is how it works inside our Rust code. So we need to have pipe 2 and pass a file descriptors to it. Let me check. Let me check this pipe 2 system call. Okay. So because we needed to connect with the pipes to our children. Pipe creating directional data channels that can be used for interpose communication. The array pipe FD is used to return two file descriptor frame to the end of the pipe and to the read. Refer to the right end. Yeah. Yeah, pipe is POSIX compatible. Pipe 2 is Linux specific. Yeah. How Golang obtains this? Yeah, we're doing a fork. Okay, pipe file descriptors 2. Okay, fork. Yeah, this is kind of understandable how they use this pipe. So this is if child p is equal to 0. So in this case, we are like currently is inside the children, and we are like reading some data from the pipe of d0, which is actually our parent. Yeah. So we are closing the right end and like reading from the read end, and I think they should send something. Right. Yeah. So I still need to like deeply understand what does it mean, how to properly use pipes, and to understand this, I think we need to dig into Golang sources. Like, let's get into std out pipe, because we also have std in pipe. Yeah, and this is kind of interesting. Child why you are so mad? Search references. Why are you just trying to insert something? Oh, yeah. Thank you. Child is std if OS open. Oh, this is kind of tricky. Yeah, OS open dev null means that just to open a file, just to open an std. So to do this, but I'm not quite, I don't think I quite understand this. So we are not inside the children. Pipe system. Yeah, well, we know this thing. I don't understand the thing that we allocate. So we are not in the we are not in the child. So how we can apply a pipe here? Okay, when we use fork in any process, file script will remain. Oh, yeah, now I understand. Yeah. Sorry, I'm just stupid. So how it works? So yeah, this file descriptors remains open. So pipe is not. This is not going to be you know, exactly std and std. That would be a pipe, just like a way to communicate with the process. And we actually don't need to write anything inside std and std. We can just write into the pipe, so without any problems, and read from the pipe. But then we will face with the following error. So our process will still, our PHP process will write not to our pipe, but it will write to our to the std and stdr, you know. Well, this is a problem. So, and that because I chose to implement to have a first implementation over the Unix socket, because so we don't need to do anything with Unix sockets. It's just copy of this resource, and we can just read and write into the Unix socket. Okay, how we can do this? Connect pipe to syscall to the stdr. We can also check the procs. So yeah, and this is as you may see here, there are a lot of processes currently running. Let's say let's get into 200, process number 200. fd, oh, we can't. Sudo no, we don't have. So inside fd folder we like obviously would have file descriptors which are open for this process, yeah, and it could be 1, 0 for the 1, 2, 3 for the std and stdout stdr. But this is we can't properly read from this file descriptors, so this is going to be a problem for us. Okay, it's not secure. Okay, I'm ready to this. yeah, this is a pair of the file descriptors, but not that we need it for, like 1, 2, and 3. Yeah, 2 lowest available file descriptors. We can do the following. We can close the std in, stdr, and std out for the process and use like pipe 3 system calls to connect to this std in, stdr, and std out. Okay, so this is also the problem. Let me check. PHP dap2. Oh, yeah, we have dap. What kind of process control extension? Oh, this is EIO. We can't close, we can't close a file descriptors of the not our child process. How it works, and Go basically do the same thing. I think it just closes. Yeah, for the stdin you can't write, you can only read. So for me, it's like I can only read from the stdin. It's like, oh no, stdin, yeah, maybe I'm correct. So I need to close it. stdr. Yeah, and PR, yeah. So, and IO copies everything from the one file descriptor to the another and closes, like for example, if we need to read from stdr, we can't write into stdr, we can only read from stdr, and we might close the read part, like here is like PR, which like pipe read states 4. Okay. So it seems that if we close it seems that if we fork our process, we won't be able to properly we won't be able to properly read from this from the pipe, and this is actually a problem, and this is why I used Unix sockets to. Okay, so but now I should resolve this problem. Yeah, we already saw this function. Yeah, child files. There are 3 plus extra files. Yeah, so we should have 3 for the std in, std std out, and you know, all, and also like copy all others, which was opened on the moment we started to clothing, like here. I know I definitely don't want to use this io.2 extension inside the PHP, because I think it would be like, do we have it? By the way, no, we don't. Installing and configuring installation pickle package. Yeah, so but this is not the standard one, it's not included into the standard distribution, and moreover it's like 0.0.1 dev. You know, this should not be used inside the production code. So basically we can do the following. PHP uses under the hood let me check. So PHP uses under the hood should use, I think, some kind of error, std error. Self writing error, self pipe out. What is self pipe out? Oh yeah. So this is std error, php std error. But we should replace, so to properly connect all of the things, we should pass. So let me check. Can we obtain a file descriptor of the like our pipe are going to return pipes pipe 2 man. Yeah, so we have two file descriptors, yeah, and when we're creating this pipe, we're going to return these two file descriptors. We can use a system call exactly like this, like syscall, like we use here in our SDK, in this pwd open file descriptor, yeah. So we can use, like, by the way, what is the number of this system call? Right, where is the number? Pipe 2 syscall number. Are you kidding me? Where is number? Okay. Don't want to be kind to me? Let me just... I'll just find you. I find you and kill you. Linux system call table. Syspipe 22 or pipe 2 293. I said as I found you. Okay, so we have a system pipe 2 system call, which is like 293. We needed to pass and structure inside it, like we passed, for example, like here, polfd, but with two arguments in it. Like it's specified here, like long file descriptor. It would be, I think, long will be mapped to uint, might be slice with uint. Oh, I'm sorry, not that. Yeah, slice. This would be a slice with uint. So we're going to pass this structure, but we're going to do it tomorrow, to the system pipe, and then here we are going to pass fork to our worker with these two file descriptors we allocated. Yeah, and instead of writing into the std error, the worker can write into the pipe end, you know. So we would have std error. Let me just std error. Yeah, this is our std error. Yeah, std out. Where is std out? Yeah, std out handler. This is also std error. Where is std in? Okay, this is PHP, so I need to talk with Anton about this. So about this update to our worker. But definitely, if we pass all of this kind of stuff, this won't be a problem. So I guess, yeah, and we are going to do this tomorrow. we'll try to instantiate this system call and obtain a file descriptors, and try to continue our investigation with this. Yeah. Okay, guys. Thank you very much for being with me, and have a great evening, and see you tomorrow on the stream. Bye bye.